There are three basic types of automotive electrical problems: shorts, opens, and high resistance. A short to ground occurs when a component has little or no resistance. Bad wiring, damaged or worn wire insulation, or a defective component can cause it. A short to ground usually results in a blown fuse, since there is too much current flowing through the circuit containing the short. Start your diagnosis for a short to ground by turning off the circuit control device and replacing the fuse. If the fuse blows immediately, the short to ground is before the control device. If the fuse doesn't blow immediately, operate the circuit. If the fuse blows when the circuit is turned on, the short to ground is located after the switch but before the load. An ohm meter is used to check for an internal short in a component. A shorted component will have abnormally low or no resistance. During this process, remember to check between all of the terminals or pins. An abnormally low resistance reading indicates an internal short. An open is defined as a break in the circuit that stops current flow. There are several things that can cause an open. They include a broken wire, an open or defective load, an open connection, or an open switch. Before testing for an open, look at the wiring schematic to identify all the loads and other components in the circuit. If the circuit is controlled with a relay, you should start testing there, as it is typically the easiest point of access. If the relay controls the positive side of the circuit, test for voltage at the output terminal of the relay. If there's no voltage at the output terminal, test the control side of the circuit. If voltage is present at the relay's output terminal, check for voltage at the load. Voltage at the load typically indicates a problem in the load itself or in the ground. If voltage is present on both sides of the load, the problem is an open in the ground of the circuit. High resistance in a circuit will cause components in the circuit to operate improperly. This is because the current flow is lower than normal in a circuit with high resistance. The most common cause of high resistance is corrosion, usually at a terminal or connector. Measuring voltage drop is usually the simplest and most efficient method of detecting unwanted resistance. To begin, check the voltage drop across the load in the affected circuit with the circuit energized. If there is excessive resistance in the circuit, the voltage drop will be less than the source voltage. To find the location of the excessive resistance, place the voltmeter between the positive battery post and the positive side of the load and energize the circuit. The meter should show little or no voltage drop. If the voltage drop is more than specified, there is excessive resistance in the power side of the circuit. If the power side of the circuit is okay, perform the voltage drop test on the ground side. Place the red meter lead on the ground side of the load and the black lead on the negative side of the battery. The meter should show little or no voltage drop with the circuit turned on. If the voltage drop is more than specified, there is excessive resistance in the ground side of the circuit. If you find a problem on either the power or ground side, you can pinpoint the cause by checking each connector in the circuit for excessive voltage drop. Place the meter leads across each connection with the circuit energized. An excessive voltage drop indicates excessive resistance between the terminals in the connector.